Welcome to the video lecture. Today's topic is the filtration. So, what is meant by filtration? Generally, filtration in the sense separating, right? So, we will be separate. What we will be going to separate in the sense through a porous medium, by a medium, we were going to separate the solid and liquid. So filtration, what is the definition of that in the sense? It may be defined as a process of separation of solids from a fluid by passing the same through a porous medium that retains the solid but allows the fluid to pass through. Means in this, what mainly in the sense it is a separation process. In this separation process, what and all we were going to separate means from the solids and liquids we were going to separate. Okay, that too how in the sense by passing through a porous medium we were going to separate. On the porous medium the solids will accumulate and through that porous medium which will go in the sense fluids will be going. So this is the definition of the filtration. Another one is the clarification. There is a only small difference between the filtration and clarification. In both the process, we were going to separate the solid and the fluid phases. Okay, but in the clarification, what will be different from the filtration in the sense? Concentration of the solid in the sample is 1% weight by volume means then you will be calling as a clarification. In the separation process itself, whenever in the filtration process means you will be telling separation, right? So in that separation, what you are going to do? Solid and fluids, liquids, you will be going to separate, right? So whenever the concentration of the solid is above than the 1% weight by volume means then that separation process you will be calling as a filtration. If it is less than the 1% weight by volume means then you will be calling that separation process as a clarification. Okay, so when solid are present in a very low concentration, that is not exceeding 1% weight by volume, the process of its separation from liquid only we'll be calling as a clarification. Then some basic terms which will involve in the filtration process means slurry, filter medium, filter cake, filtrate. What is meant by slurry in the sense suspension which we were going to be filtered, that only you will be calling as a slurry, nothing but the sample. Okay, then filter medium. What is meant by filter medium in the sense? For the separation process, you will be using one medium. That medium only filter medium. Okay, so how it will be in the sense pores? It will contains the pores with the smaller diameter. Why in the sense it will retains the sample which we were going to means solid from the sample solid it will retain on it. Okay, then filter cake, accumulated solids on the filter only you will be calling as a filter cake. And then filtrate, whatever the fluid which is passed through that porous medium, that liquid only you will be calling as a filtrate. So these are the basic terms which will involve in the filtration process. What and all in the sense slurry, which is nothing but the sample we were going to be filtered, generally suspension, and then filter medium. So filter medium will be porous in nature, and then filter cake, whatever the solid which accumulated on that filter medium only you will be calling as a filter cake. Then filtrate, so clearing whatever the fluid or liquid which passes through that porous medium only you will be calling as a filtrate. Okay, so these are the basic terms. And then types of filtration, there is different types of the filtration. First one is the surface filtration or screen filtration. What is meant by surface filtration in the sense? It is a screening action by which pores or holes or medium prevents the passage of the solids. Means on the porous medium, how it will be accumulated solids, how it will be separated, and where it will be accumulated solids. In the sense, on the surface of that filter medium itself, it will accumulate the solids. Okay, then another that because of its accumulating solids on the porous medium itself, on the filter medium itself, that's why you'll be calling it as a surface filtration. Then another one is the depth filtration. What is meant by this depth filtration? In the sense, in the name itself, it's there. Depth means in a deep. So, in this, slurry penetrates to a point where the diameter of the solid particles is greater than that of the tortuous void or channel. Means here, initially, diameter of the porous medium may be larger than the solid. Means then that the solid particles will go inside that from one end, it will go inside into that porous medium, but the other side it won't get thereby through that depth itself it will be separating the solid and the liquid. And then another, so this is how this is in the depth diagrammatic representation. So surface filtration, as we discussed, whatever the solids which we were going to separate, it will accumulate on the surface of that filter medium. This is the filter medium, this is the pores. So here the cake will be forming on the surface of the filter medium only. So that's why you will be calling as a surface filtration. Then coming to the another one, depth filtration. It will go inside and settle in the pores. Okay, so that it will go until the depth of the filter medium. So that's why you'll be calling it as a depth filtration. Then what is the main differences between that surface and depth filtration? In the sense, surface filtration and depth filtration. The surface in the surface filtration, size, particle size retained is slightly higher than the mean pore size of the medium. Means that surface filtration, when it will get accumulated on the surface itself, whenever the solids which we were going to separate, that the solid particle size will be greater than the diameter of the pores which we were using in the filter medium, then only it will accumulate on the surface, right? So that's what here the size, particle size retained is slightly higher than the mean pore size of the medium. Then in the depth filtration, here how it will be, particle size will be less than the pore size diameter. So that's why it will go into the deeper layers of the filter medium. Then another one, in the surface filtration, mechanical strength of the filter medium is less unless it is made up of the stainless steel. Means in the surface filtration, whatever the filter medium will be, we will be using for the filtration process, right? That filter medium mechanical strength, tensile strength will be less. Means it will easily get breakable, otherwise tear. So unless it is made up of, means other than the stainless steel, whatever material we were using for the surface filtration, it will be in the fragile nature or a less tensile force it will be having. Another one, for the depth filtration, how the mechanical strength will be, in the sense it will be high in nature. Then surface filtration, it has a low capacity. In the case of depth filtration, it has a high capacity. And then in the surface filtration, the size of the particles retained is a more predictable. Means because the pores, whatever the accumulated solid on the surface is having the mean diameter than the pore size, right? So if we know the pore size, also we can come to know size of the particles. Then coming to the depth filtration, here the particle sizes we can't be predict that much easily. Why? In the sense it will accumulate inside the layers of the porous medium, filter medium, right? So that's why it will be somewhat difficult. Okay, and then equipment is expensive because ancillary equipment such as the edge clamps is used. And then in case of depth filtration, it is cheaper because why? In the sense ancillary equipment we won't use. For the surface filtration, a filter medium's example, cellulose membrane filter. And then coming to the depth filtration, ceramic filters and sintered filters. So these are the main differences. One is the we can predict the particle size of the sample. In depth filtration we can't easily predict. Another one, what in the sense, the size of the particles will be retained present on that filter medium, we can easily determine because of that. And why in the sense, it is higher than the pore diameter. In depth filtration it will be smaller than the mean pore size of the filter medium, and then mechanical strength of that surface filters will be less. Whenever coming to the depth filtration, it will be high, and the surface filtration has low capacity, depth filtration has a high capacity. Then surface filtration equipment is expensive. Whenever coming to the depth filtration, it is cheaper. For this surface filtration filter mediums example, cellulose member filter. Whenever coming to the depth filtration, ceramic filters and sintered filters. Then come to the factors affecting rate of filtration. What and all factors will affect the rate of filtration in the sense, surface area, temperature, viscosity, pressure drop, concentration of slurry, and properties of the solid. These and all will be affecting the rate of filtration. If a surface area is more, means rate of filtration will be more, because through all this, if a surface is big means then it can the fluid which will be going to separate, it can easily escape, right? So that's why that the surface area is more, means rate of filtration will be more. It is directly proportional. Temperature is high means rate of filtration also will be high, directly proportional. Viscosity high means rate of filtration will be getting low. Why in the sense, because of more intermolecular bonding, so it is inversely proportional to the rate of filtration. Then pressure drop. Here the major driving force for the rate of filtration, what in the sense, pressure drop only. So whenever the pressure is getting drop decreased, then only rate of filtration will be high. So pressure drop will enhances the rate of filtration. Due to the pressure difference between from both sides of the filter medium only, it will enhances the rate of filtration. And then concentration of a slurry, how it will be affecting in the sense, if concentration is more in the scale, more means rate of filtration will be lesser, so it is a inversely proportional. Then properties of the solid, means based on its sticky nature or non-sticky nature. If it is a sticky particle, means rate of filtration will be lesser. Non-sticky particle means rate of filtration will be more. Then come to the mechanism of the filtration. What and all mechanisms involved in the sense, straining means straining means simple one, means we were going to strain the solid particles through a normal cloth also we can do. So it will be, how it will be looking like in the sense, it will be similar to the sieving. That is, the particles of larger size can't pass through the smaller pore size of the filter medium. That only we will be telling. Another thing, impingement. Impingement. Solids having the momentum move along the path of streaming flow and strike the filter medium. Thus, the solids are retained on the filter medium. Means like it will look like a depth filtration only. It will look like, means whatever the solids will be having the momentum will be moving along the path of the streaming flow and strike the filter medium, means another side it will get blocked. Then thus the solids are retained on the filter medium. Then coming to the another type, entanglement. What is meant by entanglement in the sense, it will get a entangled, it will get a entangled between the porous medium. Okay, so particles become entwined, means entangled in the microfibers of cloths with fine hairy or porous from a larger to smaller size of the particle than the pore size. Thus shows or retained with the thus the solids are retained within the filter medium. By entanglement, it will be retained within the porous medium itself, that solids. That is how it will be separating from the fluid. Another one, attractive forces. These attractive, because of the attractive forces, what will be happening in the sense, will be getting the filtration. How in the sense, solids will be retained on the filter medium as a result of the attractive force between the particles and the filter medium, as in case of the electrostatic filtration. Means whatever the solid present in the sample will be separated from the fluid due to the attractive forces present between the filter medium and then particles. Hence, it will be going to filtered. Then these are the four mechanisms of the filtration. One is the straining one, another one is the impingement, another one is the entanglement, finally attractive forces. Then filter medium, the surface upon which solids are deposited in a filter medium is filter media is a filter medium. The surface upon which solids will be deposited in the filter is the filter medium. For this filter medium, there will be separate properties. What and all in the sense, it need to satisfy all the properties. How it need to be in the sense, it should be inert one. First of all, it need to be inert one, means whatever solid it is accumulated on the filter medium, it should not react with that solids. So it should be inert. Another one, it need to have a sufficient mechanical strength. Why in the sense, the solid cake or filter cake bed is getting thickness is getting increased, means it should possess that weight, and then it should not get easily broke or fragile in nature. So that's why it need to have a sufficient mechanical strength. It need to be capable of delivering clear filtrate at a suitable production rate. Means it need to only filter the only accumulate the solid particles. It should not pass the solid particles through the pores of it. It need to only pass the it need to only allow the liquid particles through it, and then it need to retain the solids without plugging at the start of the filtration. Means it need to separate the solids, and it need to retain only, but it should not make it allow to get inside of that filter medium. So these are the properties of the ideal filter medium. So like what and all filter medium will be showing this properties, we can select as a filter medium. So what and all in the sense, it need to be inert, and it need to have a sufficient mechanical strength, and it need to be capable of delivering a clear filtrate at a suitable production rate, and then it need to retain the solid without plugging at the start of the filtration. Okay, then another two ideal properties, what in the sense, it should not absorb or dissolve the material. Means whatever the solid accumulated on that filter medium, it should not absorb or dissolve that material. And another thing, it need to show the sterilization property. Sterile filtration is required for the ancillary products and the parenteral preparations and all. So that's why sterile filtration imposes a special requirement of the pore size. It should not exceed the dimension of the bore or spores which is present in the filter medium. And then selection of a filter media depends on the following. How it will be depending in the sense of size of the particle to be filtered, and then amount of liquid to be filtered, and then nature of the product to be filtered, and purpose of a filter. So these are the selections. Filter media selection depends, filter media selection depends on these four properties: particle size to be filtered, amount of liquid to be filtered, nature of the product to be filtered, and purpose of the filter. And then coming to the different materials used as a filter media, what and all in the sense, first of all, filter paper. So this filter paper is a common medium which is offers controlled porosity, limited absorption characteristic, and low cost. Means it is a economical one, and it is less weight to transport also. Then it has a different grades and qualities, different pore sizes such as squares, medium, and fine. Means it offers in the different pore sizes. So based on our filter sample particle size, we can select the filter paper which is made up of the um, paper, cellulose paper. And then coming to the disadvantages of this filter paper, they shed very fine particle to the filtrate, observe small quantity of the liquid. As we know, paper will be showing good absorbance of the liquid, right? So this filter paper also is not no difference from that. It will absorb small quantity of the liquid from the filtrate, and also it will shed a very fine particle to the filtrate. Another filter media, what in the sense oven material. In that oven material, nylon cloth. What is that in the sense? It nylon cloth will be the superior to the cotton cloth. Means it will be having a higher quality than the cotton cloth, and this nylon cloth will be sterile in nature. Means it won't affect by the molds or fungus or bacteria. So and another advantage, what in the sense, it has a negligible absorption properties, and it is extremely strong as compared to the cloth. So first of all, it is showing mechanical strength, and then it is showing less absorption properties, and then it is not affected. Means it will be in the sterile nature itself. So these are the advantages of the nylon cloth. This will come under the woven uh, woven media. And then another one, woven wire cloth. What in the sense, made it will be made up of the stainless steel material, will be the stainless steel. And for this type of filter media, it can easily cleaned and long lasting. It is resistant to the chemical. Hence it is resistant to the chemicals. It is inert in nature. It won't allow to happen any reaction. So we can avoid the chemical reactions by using this woven wire cloth. The another one is the cotton wool. This cotton wool filter medium is a commonly used one. Small top of cotton wool placed in the neck of the funnel. Then we will going for the filtration. So it is a commonly used one. And then glass wool. When it will be using in the sense, highly corrosive materials. In that case, what and all chemicals which will make a metals corrosion. In that case, we will use this glass wool as a filter medium. And this may what is the drawback of this glass wool in the sense, it may contaminate the filtrate with its glass fiber. Why in the sense, glass will be alkali in nature, right? So that's what if the filtrate will be affected with that alkali nature, means then it will be changing in its chemical property. So that's what it may contaminate the filtrate with the glass fibers. And then coming to the asbestos. So this asbestos is one of the one of the one of the metal. This is also used for the filtering the corrosive liquid, and they impart alkalinity to the filtrate. Alkaloids may get absorbed, so it may contaminate the filtrate. Then membrane filter. This membrane filter is a very common among the ultrafiltration methods. And how it will be used in the sense, it is made up of the cellulose, polyvinyl chloride, nylon, and other cellulose derivatives. So and these they are rare, very fine, having a wide range of pore size from 8 micrometer to the 0.22 microns. So This membrane filters itself having different pore sizes. So we were going to see if what pore size means what characteristic it will be showing in the sense. If it is having a 0.2 microns means it will be showing a it will be removing all the bacteria from the filtrate, and then if it is having the pore size 0.45 micron diameter means whatever bacteria belongs to the coliforms, we can remove that, and then 0.8 microns, that in that pore size means we can remove that all airborne particles and all we can remove. And if it is 1 point microns means whatever the non-living particles which is dangerous in the IV fluid and all we can remove. And then if it is having 5 micron means all significant cells from the body fluid we can remove. Then coming to the advantages, bacteria can be removed by sieving, and absorption of medicament is negligible. In every new operation, a new disc is used. Filtration is quite rapid and don't liberate particles to the filtrate. So these are the advantages of the membrane filter. And coming to the disadvantages of the membrane filter, fine pores may get clogged easily and soluble in certain organic solutions, example ketones, esters, and then it will be very brittle whenever it is in dry form. So these are the disadvantages of the membrane filters. Then coming to the sintered glass filters. It is consisting of the Pyrex glass powder used for the filtering parenteral preparations. Parenteral preparations is nothing but the IV injections, infusions and all. Useful for, and it is also useful for the filtering the corrosive liquid and oxidizing agent, and it won't shed its particle to the filtrate. Don't absorb the any liquid from the filtrate. It can be easily washed and it can be easily maintained. Then some other filter media which we were using in the sense sand filters. It consists of the large bed of properly proportionate layers of the sand, stone and gravel used in the large scale operations such as municipal purification of the drinking water. So in generally we will be getting that from the municipal water and all will be getting how they'll be filtering that whatever the water which is coming from the ground, and they are supplying in the sense through the sand filters only. And then coming to that Berkfield and the Chamberlain filters, how it will be in the sense it will be looking like a hollow cylinder or candle. It is made up of the porous porcelain or a diatomaceous earth, nothing but a kieselguhr. Okay, then cheese filter. They are specially prepared from the asbestos filters. All this type of filters required use of the vacuum for efficient filtration. Means normally its a filtration rate will be low. Whenever you will be applying vacuum, then the filtration and all will be fast and efficient. Then coming to the filter rates. Filter rates are nothing but the materials which will enhances the rate of filtration. So that filter rates only you will be calling the substances when which when added to the liquid to be filtered reduce the resistance of the filter cake and increases the filtration. Then the objective of the filter aid is to prevent the medium from becoming blocked and to form open porous cake, hence reducing the resistance to the flow of the filtrate. And another thing, filter aid forms a surface deposit which screens out the solids and also prevents the plugging and supporting filter medium. Then coming to the properties of the filtrates. Not and all properties in the sense it need to be chemically inert, it need to be light in weight and low specific gravity, insoluble in the liquids. It forms a porous cakes and free from the impurities. Suitable particle size with a irregular shape, able to remain remain suspended in the liquids, and it need to be free from the moisture content. These are the properties need to satisfy by the filter aids. Then what are the disadvantages in the sense? To remove the colored substances by observing them, we can't, because it will be inert in nature, right? So that's what. Then sometimes active principles such as alkaloids are observed on the filter aid because of its attractive forces. Then rarely, filters are sources of contamination such as soluble iron salts, which can provoke degradation of the sensitive ingredients. So these are the disadvantages of the filter aids. Then coming to that examples of the filter aids, diatomate. Nothing but previously we have discussed diatomaceous earth, that only Kieselguhr. Then perlite, diatomite perlite, cellulose, asbestos, charcoal, talc, bentonite, fuellers earth, nothing but multani matti. And then handling of the filter aids. How we need to handle? Use of pre-coat of filter aid means what and all disadvantages for that you need to overcome, right? So for that we need to pre-coat that filter aid. So filter aid is used as a pre-coat or a layer of the filter aid is applied before the material is poured or pumped to the apparatus. It prevents the colloid particles from becoming entangled into the filter media or filter cloth, so resistance of the filter cloth will become high. Then incorporation of the material. How we will be going to incorporate? Incorporation of the certain percentage of the filter aid is added to the material before the filtration. Presence of filter aid increases the porosity of the cake, then decreases its compressibility, reduces the resistance of the cake during the filtration process. This is how we need to incorporate the material. Then use of the pre-coat for the special filters. How you will be using in this is, specially for rotary drum filter with the vacuum. Slurry of filter aid is fed on the filter aid until pre-coat is laid down. Then slurry made whatever material you need to be filtered is to be feed inside that equipment. Then what and all factors will affecting the selection of filters in the sense? Purpose of filtration. So collection, in that purpose of filtration, based on its purpose we need to select collection of the solids after washing, collection of the filter, removal of the dust particles from the air, removal of the microorganisms from air or liquid, and conditions of filtration is the pore size, chemical compatibility, maximum operating temperature, and concentration of the solid. The theories of the filtration, it will involve in the resistance rate of any reaction that can be defined as a rate, right? Here the driving force will be the resistance shown by the porous medium only. The rate of filtration is expressed in terms of the volumes and then time. Here for the rate of filtration, driving force is the pressure difference between the upstream and downstream of the filter medium. And then resistance is not constant for the filtration process because it will increases based on the pore size and based on the pressure drop present on the upstream and downstream of the filter medium.